to be doing something a little bit different, like I did differently last time. I'm not going to be teaching anything new, but rather it's more of a code along for an exercise that I have planned. Or actually, if I'm going to be honest, here on the agenda, it's actually a rock, paper, scissors game. So this will reinforce a lot of the information that we learned in the previous videos. It'll show you something cool that will be built on Python programming. And it'll be kind of like a sneak peek into my Unity courses that I'll have coming up sometime in the future. I'll let you know more on when I'm planning to record those in the curriculum that I'm having, but it's coming along. It's coming along. And I just included here an image of the rock, paper, scissors that we'll be doing. So please subscribe to the channel. I got the tutorial from this rock, paper, scissors tutorial website that I'll have a link in the description. And here's another picture of me as I've promised. So if we were to go into our new Replit script, just a blank rock, paper, scissors script, the first thing that we need is to import a module. And the module that we need to import is something that checks for a random, that's the key word, but a random kind of input. So if I were to give, let's just say random.range, just speculating here, and I have in here, I don't know, 1 to 20. So we have a list actually ranging from 1 to 19, because in Python it starts from 0. But from 1 to 19, it's going to pick out a random number. So that's essentially what we're doing here, but in rock, paper, scissors, it's going to be a computer playing against you, and the computer will pick a random value, rock, paper, or scissors. So how we do that is we import random, and that will essentially just allow us to randomize. And the next thing that we need is our first variable. So we're going to call this user action, and we're going to set that equal to an input function. If you're confused on what that is, check the Python documentation or check one of my previous videos, because I do definitely explain what that is. And here we will just go enter a choice. And I have here rock, paper, scissors. And make sure that's all closed in quotes. Oh man. It's not reading it right. But that's how it should be. Rock, paper, scissors, colon, and we add that space. So if we were to run it, you can see that space is included to make things look clean. If I type in rock, nothing happens because we didn't write anything else. The next thing we need is another variable, possible actions, right? Because we're getting the possible actions that we can input. And here we will have a list. So I didn't really go into what lists are, but just think of them as like a list of things that we can store inside. So like I can have a string, I can have a boolean, I can have an integer. Like these, it'll take all of those. So in this possible actions, what we want is we want rock, right? Because that's one of the inputs that we're expecting from our player. We're expecting paper, and we're expecting scissors. And keep in mind, if something is spelled differently from your input, so if I did like a capital R, then it wouldn't be read here. Now there's ways to make it so that way, if it's a capital R, all uppercase R, all whatever, just something different from this list that still gives us the similar value, it can read that, but I'm not including this in this exercise. And we have our two variables, and then we also need one last variable, computer action. And that will be where our module will come from. So random dot choice, and here we have our possible actions. So what we're doing here is we're calling computer action, and that's equal to a random choice. So the random choice comes from these possible actions. You're either choosing rock, paper, or scissors. And this is what the computer will be reading. It'll be checking for your input. So this is, if I like to explain it, like a person. In especially object-oriented programming, we have it like a person. We have here's our head with our modules and our variables. Now we just need the body, which essentially is where all the programming is going to happen. So how we do that is, we'll need to check if something is something else, and we do that by doing an if statement. So if user action is not in, and here we're including this because we want to check that if somebody types in gun or lizard or Spock, if you know what I'm talking about, then we want to make sure that it'll boot them out. It's like, hey, please pick an appropriate answer. Don't do that. And how we do that is we have this if statement, not in, and this is a different way of writing the exclamation point and equal. So it's not in, and we have possible action. If it's not in our possible actions, then we're going to print please, oh, if I can spell please right, please input a correct answer. So this is how it'll look so far. Enter a choice. I type in rock. It's good. Nothing is supposed to happen. But if I type in gun, please input a correct answer. So this all here is our head. Now, to finish this off, because you can't write an if statement without having an else, and our else, you know, if essentially our else is, okay, if they typed in rock, paper, scissors, else, you know, print. And here we're going to do a new concept. It's called an F string, and I'll show you essentially what it does. So how we do is we type in F with our quotes, and we do F dash N. So this is a way of calling a new line. You chose brackets, user, action. Now, while computer chose computer action. And then we'll just call in a new line to make things look clean, and we'll finish that off with a quote. So, by including this F string, it's allowing us to concatenate our variables, whatever variable that may be, into this whole line. So if we were to run this, and we type in rock, you chose rock, computer chose scissors. Now that's not, you know, this is not done yet. We still need the body of our program. We need our program to think. There's no thinking going on here. It's just randomizing, you know, it's making a random input and playing with you, but that doesn't really make much sense. We need actual logic to back this up. So don't get excited that this works, because it doesn't. But you can see here that by including this /n, which you can see right above your return keyword. So I'm on my Mac, and that's above my return key. It's giving us a new line. Same with here. And user action, computer action allows us to do rock and scissors. That's all possible through this F string. So now let's write our body. So how we do that is, and I prefer to write it this way because it's cleanest. So I want to call a function, which it's not necessary, but it definitely makes your code clean. And we call the function with def, and then I'm just going to call this game func, short for function. But call it whatever you like, but just keep in mind when you're programming, call your methods based off of what they actually do. So because we're just doing all of our thinking, our rock, paper, scissors thinking in here, it doesn't really matter what we call this because we're not going to have other methods. But make sure that this is similar to what's going on in the body. If it's just unicorn and you've got like rock, paper, scissors stuff, programmers are going to look, oh, that's unprofessional of this person, and you might be fired. So that's not a good thing. So the first thing we'll write is if we get a tie. So we do that if user action is equal, double equal computer action. Now, this is asking if rock equals rock or if paper equals paper. Now we go print, and here we have another F string. Print both players selected, and here we'll just concatenate what our player selected. User action. It's a tie. So essentially what we're doing here is we're kind of saving ourselves the work by going both players selected, and we're just calling user action, which is our variable. You know, it's not the computer's variable, but we're both getting the same thing. So if I were to choose, and I don't know if this will show, you chose rock, computer chose scissors, right? It won't show, but if we keep on doing this and the computer chose the same value that I chose, then we will get this spit back at us. Now, what we'll write next is we'll include an elif statement, which is continuing with our if statement. Elif user action equals rock. So if we chose rock, what's going to happen? If we chose rock, then if computer action equals scissors. So now if we chose rock but the computer chose scissors, what's going to happen? And we just say rock smashes paper, scissors, excuse me. You win. So again, this is if we tie. Here we'll write a quote, comment. This is for a tie. While this is if we get rock, computer gets scissors. So that's how it's gonna work. Now, what else would happen? And here we do it right here because we want it to align with this if statement. So if computer chose something else, but we still chose rock, else print paper covers rock, you lose. So this is assuming that computer chose the other value that wasn't specified because it's 3 values. So that's a pretty clean, smart way of writing this. And that is the computer getting scissors and we getting rock. Now, I smell a shortcut. I'm not sure if you guys can see the shortcut. Let's just assume that our logic is the same, just with different values. Huh? We get rock, so let's say we get scissors. Or actually, let's say we get paper. Let's do paper, keep it consistent. And let's say they got rock. Now, it's all going to stay the same. Only we'll change here. This is paper. They've got rock. And what are we going to say? Well, we're going to say paper covers rock, you win. While we say, guess what we would say? Any guesses? No? Alright. Well, we would say similar to, right, let's see, paper, rock, and then we would say, if they chose scissors, then scissors cuts paper. You lose. Well, that sucks. Let's hope I don't lose. And then we would do the same thing here. Now let's just assume that we chose scissors, and they chose, I don't know, we chose rock, they chose scissors. Let's just assume they chose paper. So we would say, we can cut from here. And you can see how this code works. It's pretty straightforward once you've got the programming involved, the logic, I should say, because then we can just go here, rock smashes scissors, you win. While we would, and now if they chose paper, then we would say paper covers rock, you lose. And this is our body of our game. So that is what is going on in the body of our game. Now, our legs, which is how we cap everything off, we do that by calling something. So like a common program in Python that I'm sure you're familiar with is if we have a variable at the top and we want to call that variable, then our legs would be, print hello world, for example. If I can spell hello world, I've had issues with spelling lately. I'm just going to be honest here. But our legs would be calling our game function, this entire body of code. We do that by running. So if we run it, we do rock. You chose rock, computer chose scissors. Rock smashes scissors, you win. So you can see the code is shuffling through, the computer is shuffling through all of this code, trying to differentiate what it decides. And it's all possible through this module all the way at the top, import random. So let's say I chose gun. Well, please input correct answer. And I'd have to run it again. So a challenge I will give for you is, let's see if you can wrap this in a loop. There's a while loop that you can use. This is a concept that we haven't gone over. There's a while loop you can use. You can find that on the internet somehow. So that way it'll just loop through the program once you finish. Or there's a for loop. And for loops are probably what I would recommend more. So we would come all the way at the top here and go for x and x, and then you'd finish the code, and then it would just loop through all of this. But be careful when you're looping that, your computer could break, anything could break. It's like the most ghetto virus that you could put on a computer, because it'll go an infinite number of times unless you shut it down. And you have to shut it down with break. That's all you need to, kind of like return. All you would have to shut down a loop is with break. But again, this is teasing for another video. I'm not going to go in depth in any looping, but this would be, you could easily incorporate looping into this code. Now, I have another rock, paper, scissors exercise I can go over, but I'll go over that in another video. So for now, I hope this helps. It's a It's a very cool game that you could show anybody you're interested in. And yeah, stay tuned for more Python videos.